So in the last video, we went over 7.1, which was on multiplying monomials. This lesson, 7.2, we're working on dividing monomials. So when we multiplied monomials that have the same base, we added the exponents. So x squared times x to the fourth became x to the sixth. When we divide them, we will subtract the monomials. And I'll show you an example here of why we do that. So if we have, actually I'll go with the same one that's on your notes online, so if you're following along with that. If we have x to the fifth divided by x squared, if we were to write that out and go the long way with this, x to the fifth, we're multiplying x by itself 5 times. Then we're dividing by x squared, or x times x. Now, if we look at this, it's kind of like a fraction here, and we know that we can simplify our fractions. If we have something that shows up in the numerator and the denominator, it cancels out. So this x cancels with that x. We can cancel out 2 of those x's. Then what we're left with is x times x times x, or x cubed, over 1, which would give us x cubed, which if we look at this, x to the fifth divided by x squared, like I said, we're going to subtract the exponents. So we could say x to the 5 minus 2, which equals x cubed. So again, this is just kind of writing it out the long way to show you why we subtract when we're dividing monomials. So let's get into some examples here. So quotient of powers. If we have a to the fifth times b to the eighth over a times b cubed. What this is really saying, if we separate it, again, you don't have to do this. This is just kind of showing you how this works. We can separate this into 2 different division problems. We can say a to the fifth over a times b to the eighth over b cubed. Now, a to the fifth over a, if we go ahead and subtract our exponents, a to the first, so we would have 5 minus 1 gives us a to the fourth, then b to the eighth over b to the third would give us 8 minus 3, so b to the fifth power. So that's what we do when we are dividing monomials here. The second example that you have in your notes is x cubed times y to the fourth over x cubed times y squared. Now this one, if we don't separate it out, if we just go through and solve it right away, x cubed divided by x cubed gives us 1. Anything divided by itself is 1. Y to the fourth divided by y squared, so 4 minus 2 would leave us with y squared. We can get rid of that 1 in our answer, and we would just have our answer of y squared. So then the power of a quotient. So what that means here is if you have a division problem raised to a power. So in this case, we have 2p squared over 3 raised to the fourth power. So what we need to do here is, if you look at the notes, it tells you when a fraction is raised to a power, you must raise everything to that power. So just like on the last one, when we just had 2p squared to the fourth power, we had to distribute that fourth power into the parentheses. Here we also have to distribute it into the denominator. So this would become 2 to the fourth power, which would be 16, times p squared to the fourth power. Remember, if we're raising a power to another power, we multiply. So 2 times 4 is 8. Then it would be over 3 to the 4th power, which would give us 81. Now again, you want to make sure it's simplified. We only have each base shows up once. Fractions are in their simplest form. In this case, there is no number that goes into 16 and 81. So this is simplified. That's as far as we can take that problem. Let's walk through another one here. 5x to the 5th y over 4x raised to the 3rd power. So again, we have to raise everything in this fraction to the 3rd power. So first we're going to go 5 to the 3rd power, which gives us 125. X to the 5th to the 3rd power would give us x to the 15th, 5 times 3. Then y to the 3rd power over 4 to the 3rd power gives us 64. X to the 3rd power gives us x cubed. Now we need to simplify this. There's no number that goes into 125 and 64, so we know those numbers will stay the same. X to the 15th divided by x cubed. Here, since the numerator has a higher power than the denominator, we're going to cancel out the denominator, and then the numerator would become x to the 12th, because 15 minus 3, since we're dividing, we subtract. 15 minus 3 is 12, and then our y cubed stays the same because we do not have a y in the denominator. And that would be the simplified version right there. Next, we have the 0 exponent. As it says in your notes, any number or variable to the power of 0 is 1. So in this case, the first example we have there, 2x squared y cubed over 4x y to the 4th, all raised to the power of 0. Now in this case, like I said before, any number or variable raised to the power of 0 is 1. So here we know we have to raise everything to this power, which 2 to the 0th power is 1. X squared to the 0th power, 2 times 0 is 0. X to the 0th power is 1. Y cubed to the 0th power, again, 3 times 0 is 0. Y to the 0th power is 1. You get the pattern here as we continue. Again, we get 1 times 1 times 1 on the bottom. Gives us 1 over 1, which is an answer of 1. Now let's walk through the second one. X to the 7th, y cubed over x squared, y to the 0th power. Now, what we can do here, there's a couple ways we can go ahead and solve this one. We can just look at it here and we know that if we divide x to the 7th divided by x squared, we subtract our exponents. So 7 minus 2 leaves us with x to the 5th power. Then same thing here. Y cubed divided by y to the 0th power, 3 minus 0 gives us 3. We have our answer of x to the 5th, y to the 3rd. Now the other way we could have solved that is we could start by saying the numerator is going to stay the same, x to the 7th, y cubed over x squared. In this case, we get rid of our y to the 0th power because we know that's 1. So we could put a placeholder in here of times 1, but we don't need to do that. Then as we solve this, again, x to the 7th divided by x squared gives us x to the 5th. And we're still left with y cubed. So again, a couple different ways of being able to solve that one. Then the last thing on this lesson was negative exponents. Now again, I have it typed into your notes there. If there's a negative exponent in the numerator, you make it positive and move it to the denominator. If the negative exponent is in the denominator, you make it positive and move it to the numerator. So I had an example there where I said that a to the power of negative n would become 1 over a to the positive nth power. Because really, a to the negative n, we could say, is over 1. So we flip that fraction and make the power positive. So if we have x to the negative 4th power, that would become 1 over x to the positive 4th. Now if we look at it the opposite way, that's if we have a negative in our numerator. If we look at it as having a negative in the denominator, if we have 1 over a to the negative 3rd power, then we, again, like I said, move it to the numerator and make the power positive. So this would become a to the positive 3rd over 1, which is just a to the 3rd power. So let's go through a few examples that include these. The first one that we're going to walk through is b to the negative 3rd times c squared over d to the negative 5th. So here, b to the negative 3rd, since it's in the numerator and it has a negative power, that's like saying b to the negative 3rd over 1, which we need to flip to be 1 over b to the positive 3rd. Then we have c squared, which we would write as c squared over 1. And then we have d to the negative 5th in our denominator, so that's like saying 1 over d to the negative 5th. Since it's a negative power, we need to move it to the numerator then, and it would become d to the positive 5th power over 1. Now we multiply straight across. In our numerator, we would have c squared times d to the 5th over our denominator of b cubed. Now, you don't have to do this long way every single time. I was just showing you the steps. But if you think about it, really all we did to solve that problem was take our two variables that had the negative exponents and we flipped where they were and made the exponents positive. So let's do another one there. We have x to the negative 4th times y to the negative 3rd times z to the 4th all over m squared times n to the negative 3rd power. Now if we do this without taking all the steps we did on the one up above, we can look at it and just say we have x to the negative 4th, y to the negative 3rd in our numerator. So we have to take both of those and move them to the denominator. We have n to the negative 3rd in the denominator, so we need to move that up to our numerator. So this would then become n cubed. Remember, when you move it to the numerator, it becomes positive, times z to the 4th over m squared times x to the 4th times y cubed. And that would be our answer. We can't simplify it anymore because each base only shows up once. So let's do one more example here of this. This one's going to include a couple of extra steps as well. So here we have negative 3 times a to the negative 4th times b to the 7th over 21 times a squared times b to the 7th times c to the negative 5th. So doing this problem here, the first thing I'm going to do is if I take a look at my coefficients, those can be simplified. Negative 3 and 21, 3 goes into each of those. So negative 3 divided by 3 gives us negative 1. 21 divided by 3 gives us 7 in this case. So now, what I'm going to do is I'm going to divide my a's. So a to the negative 4th divided by a squared. Remember, when we divide monomials, we subtract the powers. So this would become a to the negative 4 minus 2, which gives us negative 6. Then b to the 7th divided by b to the 7th, those cancel each other out. Then here, since we don't have a c value on this one, we can write in a placeholder of c to the 0th power. When we subtract, we have c to the 0th power. They're actually, I'm not going to make it that confusing on you. We're just going to leave it how it is. Since we don't have a c value on the top, the c value stays on the bottom as a negative. So sorry for that confusion. Since we don't have a c value on the top, we're just going to leave it how it is in the denominator. So now when we look at this, we know if we have a negative power in the numerator, it needs to move down. If we have a negative power in the denominator, it needs to move up. And then they both become positive powers then. So this would then become negative 1 times c to the 5th over 7 times a to the 6th, which could then simplify to just negative c to the 5th over 7a to the 6th. That's simplified as much as it can be, so that would be our final answer. So again, that's dividing monomials. Just like I said on the last video, if you have any questions at all on this, please feel free to reach out. I want to make sure you guys understand this. This is something that you'll continue seeing as you move on in math, and so I really want to make sure you understand what we're doing here.